thank you very much for coming out here. I've been in meetings for the past few hours, but I'm assuming that it's still stormy out there. So if it is, thank you very much for making it out here to be part of this public forum. My name is Stephanie Michaud, and I am President and CEO of BioCanRx. And on behalf of BioCan and our Summit for Cancer Immunotherapy, I wish to extend a very warm welcome to everybody here in the room, and thank you for coming to our public forum. We're what is termed a network of centers of excellence, which is a network of different academic centers from across Canada. And we work with our many partners in discovering new ways to enable the body's own defense mechanisms to outsmart and to kill cancer cells. We're accelerating to the clinic Canada's most promising and innovative cancer immunotherapies designed to save lives and enable a better quality of life for those living with cancer. Assembled at this conference that's been ongoing now for about 2.5 days are more than 330 of Canada's and the world's leading scientists, clinicians, students, health economists, and we're meeting at this week's summit along with representatives from industry, from patient groups, charities, and government. We're exploring together the latest progress in cancer immunotherapies, and we're pleased to share some of these insights with our local community. So it's a great pleasure for me to introduce the President and CEO of the Ottawa Regional Cancer Foundation, Linda Eagen. And I have a few words here to say about you, Linda. Yes, so you're going to sit there and listen? No. Inspired by W.A. Ward's quote, "If you can imagine it, you can achieve it, dream it, and you can become it." Linda Eagen's dream is to change the cancer experience for families in our community, families like her own. To that end, Linda's involvement within the Ottawa Regional Cancer Foundation began 14 years ago, first volunteering as a member on the board of directors, and then transitioning into campaign director, and for the past 10 years, serving as the Cancer Foundation's president and CEO. In this role, Linda ensures cancer remains a priority year-round in our community. Through supportive research and clinical trials and through the delivery of cancer coaching, the Ottawa Regional Cancer Foundation is changing the cancer experience. The ORCF is giving families access to the best personalized cancer treatment and care right here at home. With her lifelong career in the not-for-profit industry, combined with her entrepreneurial spirit and business education, Linda brings a passion for fundraising and a love for change and innovation that continues to help the ORCF thrive in our community. And I would like to pass it on over to Linda Eagen. I'd like you to join me in welcoming Linda to the podium.
If you can imagine it, you can achieve it. And if you can dream it, you can become it. And that's just not, it's not just a plaque on my wall. It's truly something that I live by. And I have to tell you that today, half of the time, actually in the last 2.5 days, half of the time that I was listening to these brilliant people and the work that they're doing in the realm of cancer therapy, I did think I was dreaming. I did think I was dreaming because there's so much happening, so much is changing. There are things in my body that I didn't know were there. And it turns out they're supposed to be there. And what's happening in cancer, it's not just about that tumor. You know, it's about that cell and how it interacts with that bacteria. And there's a T cell and a B cell and an NK cell, a natural killer cell. I have those in my body. I was like blown away. I could not believe everything that I've learned. And BioCanRx is championing that change and is going to make a difference in all of our lives, in the way that cancer affects us physically. But cancer affects us in other ways as well. And so there are other things that have to change. Our role in the whole cancer care dynamic has to change. We are patients. We are not passive people. We are active people. We can make a difference in the way that cancer impacts our life beyond the tumor. We have to work side by each with these guys over here. We have to help them understand what we think are risks and benefits associated with research, what we want in terms of clinical trials, so that more of us are there to help advance that research. And we have to have different conversations with our medical professionals, for sure. And so the role of the patient is changing. And I encourage you to reflect on that and think about how you're going to live that change and what it's going to mean for you and your family. And to help you in that reflection, it's un grand plaisir de souhaiter la bienvenue à une personne extraordinaire qui a connu ses propres défis et puis qui a le courage maintenant de s'asseoir parmi nous pendant une dizaine de minutes. I can tell you, I know you're going to want to hear Ramona for longer than just 10 minutes because her story is just riveting and full of things to take away. But we will spend 10 minutes talking to a patient who took control and was active in her care. Ramona, please join me up front.
Well, I'm so excited that you're taking the time to do this.
I'm excited to be
I
here.
think people here are as excited as I am, but I'd like you to introduce some people that I think are just busting with pride here in the front row.
Yes, absolutely. And I am busting with pride as well that my husband, Audie Bietlot, who's been on this 2.5-year-old journey with me, as well as my daughters, Dominique and Zoe.
Salut. So tell us, let's start from day one. Are you okay with that?
Yeah, absolutely.
Why don't we start with the day somewhere in 2014?
Yep.
Where, after some months of treatment,
Yep.
You had another decision to make
Yes.
because the cancer had spread.
The cancer had spread. I was diagnosed after being 7 months on interferon. Interferon bad. So the cancer had spread, and so my first instinct, after having been off that treatment for several weeks and actually feeling healthier and normal and myself, sort of myself again, I would have done anything not to have gone back on treatment of any kind whatsoever. So I said, I just want surgery, just cut it out of me, get rid of it. And so my oncologist, Dr. Song, bless her heart, I love her, sent me to the thoracic surgeon, and she convinced me that was not the best option. Highly invasive, missing a lobe of your lung, blah, blah, blah. Anyway, so I went back to Dr. Song and she says, you know what? There is a new clinical trial that I think you would be a candidate for, a very good candidate. I think you'd be highly successful on this. And I went, what? And she goes, but it does come with some. So I said, you know what? Bring it on.
Did you even know what a clinical trial was at that time?
I had heard of it. You know what? Initially, I'd heard of it through my previous oncologist, Dr. Young, but I hadn't qualified for a clinical trial before. But this one came up this time, and so that was the first. And I went, okay. And she handed me the documentation. I was like, what? Like, I have no other. That was it. And I was like, okay. And she said this, and so I did my research. The success rate of this clinical trial was quite good. So I said, well, it's better than interferon, but you know what? I can do this. So I mentally and physically prepared myself for this. And part of that entailed taking a lovely vacation with my beautiful family. And then I came back ready to tackle whatever came.
And how did you, were you afraid? Or did you have everything you needed? Did you know everything you needed to know? Where were you emotionally around this?
You know what? I was basically, it was like, okay, this is what I got to do. I got to get through this. So I thankfully was recommended to the Ottawa Integrative Cancer Centre, where I met with a naturopath, and she was amazing. And I said, I handed her the the sheets on the different drugs I was going to be on, and I said, this is what I'm going to do, and I need you to help me to get into the best shape that I could possibly be in physically to tackle this. And and she did, and so I felt confident, and I went under, I took care of myself physically really well up until the time that I started the treatment. So I did everything I could.
And what was the treatment like? Was that hard? Was it,
what?
compared to what you did before?
Honestly, it was it was a walk in the park. It was amazing. It was a miracle. It was like I was waiting for the other shoe to drop, because Dr. Song, every couple of weeks I'd go to see her, and she'd be like going down the list of the different symptoms, because when I signed the clinical trial, the sheet of side effects was like pages long, and I'm like, oh my gosh, what's going on? Anyway, and then nothing happened. She's like, well, she says, it could still happen, and I'm like, not going to happen. Not going to happen, and it really didn't. It really, not to the extent of the interferon, where I was literally incapacitated. Crazy.
A big difference.
It was huge.
So there's some people that probably would like to know what type of immunotherapy.
So I was on a combo of Yervoy and nivolumab. And so you do the combo drug for 4 infusions once every 3 weeks, and then you drop the Yervoy and you continue on with the nivolumab for an additional 48 weeks. So it's a year in total. And so next Friday is my last treatment. I am currently NED. So yes, I'm so stoked for that. It's like, so stage 4 metastatic melanoma, and I've made it the whole year, and I've got one more treatment to go, and then hopefully I am done. But this was a miracle drug. It just crazy how fast it worked.
So, you've got such an amazing attitude, and then clearly you've had a positive experience.
Yes.
So there's somebody sitting right there, and they're thinking, they're in 2014, they're thinking
Yes.
like you, what should I try this clinical trial? What do you want to tell that person?
Go for it. Do whatever you can not to do interferon, because
You should stop picking on interferon.
so I don't do it. Well, you know what? It was, Dr. Song was the one that said to me, like only 50% of the patients choose to do interferon, and of those 50%, only 50% ever finish it. It's that bad, and it is that bad. And so the clinic, if I had known, like if I could have just skipped to the clinical trial to doing the immunotherapy, like I would have, like I feel like I would have been one step ahead. But it's amazing. It's amazing what this has done for me.
Sorry, I'm almost left without questions because it's
Okay.
you should be a poster child for this new therapy.
You know what? That's what Dr. Song said. She's like, she says you're the poster child for this immunotherapy, and I went, well, yes, like it's great, it's fantastic.
Is there a lesson learned though? Is there some little place through that journey where something was a bit of a barrier, a bit of a challenge, and you managed to come around it? Teach us a lesson here.
You know what? I think a big part of it is when you get that diagnosis, not to let this, take over. Not let your head get, ahead of things, and just have hope and continue to be, to know that there's all these fabulous researchers and fabulous doctors doing amazing work, and there's always going to be something around the corner, and not lose hope, and always know, like keep hope in your heart, and know that there's going to be something there. It may not be this week, it may not be next week, but just you've got to keep going, the attitude, and keep your spirit. That's it. That's all I got to say. Yeah.
That's all you have to say.
That's all I got to
That's
say.
so amazingly inspiring. Please join me in thanking Ramona.
Oh,
and it's time to hear from our lovely team of experts. I will give you some background on each of them as they get up to speak, but just so that you know who's in front of you and who's going to dazzle you with their knowledge. We have Dr. John Bell, that everybody in this room, I'm sure, knows. Who said that? I'll introduce him in just a second. I wanted to go through everybody. And we have Marcus Butler and Harry Atkins. And so Dr. John Bell is somebody that I've had the great pleasure of knowing since day one at the Ottawa Regional Cancer Foundation, and who continues to lead the way in doing great things. Officially, he's a senior scientist at the Centre for Cancer Therapeutics at the Ottawa Hospital and a professor of medicine at the University of Ottawa. He heads the Canadian Oncolytic Virus Consortium, a Terry Fox-funded group, and is the director of the BioCanRx Program for the Ontario Institute for Cancer Research. He's the scientific director of the Network of Excellence, BioCanRx, and is a fellow in the Royal Society of Canada. He is a pioneer in the discovery and the development of novel class of targeted cancer therapeutics, oncolytic viruses, or as I first learned to call them from you, cancer-killing viruses. Dr. Bell has been influential in driving this new area of therapeutics. His continuous stream of groundbreaking scientific discoveries has propelled oncolytic viruses forward and led to practical applications for clinical medicine. He has spearheaded Canadian clinical trials using oncolytic viruses, including a landmark first-in-man trial using the oncolytic virus Maraba virus, in combination with a cancer vaccine approach. He is amazing, and he's going to speak to us now.
Okay, so I got to do this thing here first. Oh, there it is. Perfect. Great. How do you play it? Okay. Great. I really appreciated Ramona's comments, actually, especially when she said that we were fabulous. I thought that was good. You're referring to our fashion-forward dress, I'm sure, so I appreciate that. I'm going to tell you a little bit about some of the work we've been doing. The title of my talk is Oncolytic Viruses. As Linda mentioned, these are viruses we've designed to kill cancer. And the title I use is Programmable Cancer-Killing Machines. And so I want to give a little bit of context to what I'm thinking about when I talk about this concept of making cancer-killing machines. Because these are biotherapeutics. We're going to hear about immunotherapy from Marcus and Harry as well. And they're all in the same sort of class of therapeutics, which I'm really excited about and think I have a chance to really make a difference for all of us. So really the inspiration for this concept of a cancer-killing machine came back in 1966 when I was a prepubescent boy, and we'd go to the movies. And one of the movies I saw was Fantastic Voyage. So I don't know if anybody's old enough to have seen this movie, but it was some of you see it? Yeah, so it was a great movie. At that time, the special effects were amazing. And in this one, the President of the United States, I think it was, had a brain clot or something like that, and they couldn't get it out by any other way except to use a little machine that would fly through your blood system. It was a submarine. And the way they got it was they put scientists inside it, and they shrunk them down inside this little machine that would sail through your bloodstream, and they use laser guns and so on to try to shoot that clot out and blow it away. And I thought that's it's an obvious solution to all our problems, is to make little tiny submarines we can drive around inside people with. So at the time it seemed logical. And the other part about the movie that inspired me, of course, was Raquel Welch. And at that time, between my testosterone and that was just beginning to emerge, and this, it really created in me the idea that we could make machines to fly around inside of us. And although that really didn't inspire me to do this, it's you think about the things in your life that you think back on afterwards. But what we're trying to do is create machines like this little submarine that can go around and find the cancer within your body and attack it. And that's really sort of what we got to. So when we started thinking about this, as Ramona mentioned, she had a lot of challenges in her treatment. She was actually on a hormone called interferon, which has a lot of unfortunate side effects. But this is similar with things like chemotherapy, which unfortunately not only do they attack the cancer, but they also attack your normal tissues. And so if I said to you, I know a woman who's going through breast cancer therapy, a picture like this might come to your mind because the therapy attacks not only the tumor, but also the normal tissues. And this is really what we call dose limiting. That you get to the point, as Ramona did, where she says, I don't want that treatment anymore because it's actually attacking her body as much as the cancer. And so we all try to get to what are called cancer targeted therapies, therapies that only attack the cancer and leave your normal tissues alone and intact. And so really that's what inspired this entire field that you're going to hear about tonight. And I'm going to tell you one aspect of how we've designed therapies to try to be very specific to attack the cancer only. And also, I think the other thing that we've learned over the last 10 years is that we can really take advantage of what's inside our bodies. As Linda was saying, we have all sorts of immune cells in our body, and we have to find a way to re-educate them and get them attacking the cancer, because that's something that we could do ourselves to fight our cancer. And that's really part of the whole mission behind what all of us are doing. So just to give you a little context, I just want to speak to you about the concept of how we're put together. So we're all made up of what we call cells, billions and billions of cells. Is there a pointer here? I want to push the wrong button and turn the slides off. Okay, yeah, so we're made up of billions and billions of cells, and inside each cell is genetic information that's used to program our bodies to make us look like what we look like. And so if a cell was as big as this, a virus would be as big as this. Genetically very simple, physically very small. We can't even see viruses with a microscope. We have to use electron beams to visualize them. So they're very, very tiny. In fact, they're so simple genetically, they can't really replicate or grow on their own. The only way viruses can grow is to move inside of a cell, one of the cells in our body. So this would be like the flu virus, gets inside your throat, enters into the cells of your body, and then use the cell's machinery to make copies of itself. Okay? And then it moves on to the next cell and does it over again. So really, viruses are true parasites. They can only live inside cells, they can only replicate inside cells, and so they really need that to make themselves to continue to exist. And so we understood that biology. We said, can we actually make viruses that aren't just parasites of, say, our normal cells, but parasites of only cancer cells? So the only place they can replicate is in a cancer cell, and they move from cancer cell to kill it. And so we now have done that. We've designed viruses to be parasites of cancer cells. And I'm going to just give you an example of one of the first viruses we tested. This is a virus called vaccinia virus. This is what it looks like. Sort of shaped like a, oops, make sure I don't push the wrong button. Shaped a bit like a football. Again, it's so small we can't see it with a light microscope. We have to use electron beams to take these sorts of pictures. And we created it by what we call genetic engineering to change it so the only place it can actually go in, the only cells it can enter and replicate in are cancer cells. And this is a virus which has now been taken forward from originally from the lab. It's now gone into clinical studies, and it's in the last phase of clinical trials to treat liver cancer. And so that's just some of the ways that we engineered this virus. So I'll just give you a couple of examples of how this can work when it does work. Okay, and it doesn't work all the time. I'll tell you right now, it doesn't work all the time, and that's part of our challenge, is to find ways to make it work all the time. So this is a gentleman who had liver cancer, but beyond that, you can see this is obviously on his neck. He had a large tumor that was growing on his neck, and we were allowed to treat him on a trial, much like Ramona went on. And we were able to show that after a few weeks, he had a great resolution of his tumor. In fact, he had a response throughout his entire body. And that was the first hint we had that, in fact, maybe these viruses weren't just killing cancer cells, but perhaps they're also awakening our immune system so they could fight cancer throughout the body. This is another gentleman who had kidney cancer. So if you look at this scan here, this is like looking through his body in this direction. And he has this large tumor inside the red circle there. And that's before treatment, and then after treatment, you can see it completely went away. And so really fantastic responses. So when this works, it's much like in Ramona's case, it's amazing how well it works and how quickly it works. This is a woman who is in Hamilton. This is a part of her liver here. This is the nose of her liver. And this ugly thing's hanging off the end is a tumor. She's been told that there's nothing they can do to treat this tumor. It's going to continue to grow and kill her. And after treatment, you can see it changes, and eventually it disappears. So this is 3 examples of patients that we treated where we had these spectacular responses. We were really excited about this. But the reality is this happened only in a minority of patients. And so when we first started doing these studies, we said, oh, that's great. If we could only make it happen more often, we'd be really, really excited. And so that really is a challenge for us to understand why these people we call elite responders respond, and how can we make it so it happens more often. Okay? And so what we then discovered is, in fact, these viruses not only attack the cancer, but they what we call engage our immune systems, make our immune systems wake up and say, this cancer's here, it shouldn't be here, and then attack it so we can attack with our own body systems. And so the way we discovered this actually was an experiment done by Kelly Prado, who's around here. She's sitting back there. She now works at BioCanRx, but she used to be in my lab working, and she came up with an idea to test an idea that she thought perhaps viruses could stimulate our immune systems. And so she did this very simple experiment where she put a tumor in the back of a mouse, and it grew a little lump there. This is just a cartoon, but she implanted a tumor in a mouse. She then treated it with a virus, and she cured the mice, and that was great. All these mice were cured, and then she kept them around for another 7 months, which is a long time in a lab. To live 7 months for a mouse is miraculous because we try to kill them. But basically, she kept them for 7 months, and for a mouse, that's about half its life. So it had cancer, she cured it, and then she said, okay, I'm going to try to give it cancer again. And when she did that, she found that all the mice rejected the tumor. So the tumor couldn't grow back again. And that really gave us the hint that maybe the virus was not only attacking and destroying the cancer, but also stimulating the mouse's immune system to recognize cancer as foreign. If it tried to come back, it would keep it away. And this is, I don't know how long ago, that's 12, 15 years ago that we first found this, and we said, okay, that tells us something. It tells us that we should make these viruses not only so they can kill the cancer, but that they can also stimulate the immune system even better. And so I'm just going to very quickly end here and tell you that my colleague, Dr. Butler, is going to speak a bit more in a minute, and Dr. Atkins about the concept of immune cell therapy. And in this idea, this is a normal part of our body, the T cell, which is an immune cell, and we want to train those cells so they can attack the cancer cell. And you're going to hear some really spectacular stories from these two gentlemen about things that could be done and how it could work. And so what we said is that's great, but again, this strategy of getting your immune system to attack the cancer works, and it works really, really well, like it has in Ramona, but still not in the majority of patients, still will be in the minority of patients. And so our plan now is to say, we know that viruses can work really well, we know that they engage the immune system, we know that immune therapies can work really well. Let's put those two things together and have those be a new approach to combine therapies to attack cancer. And in fact, Marcus and I recently got a grant from the Ontario government to do this, to test this idea, to combine viruses and immune therapy together. We're hoping to start that sometime next year. So just to end by saying, I think in the past, when we had patients who came to the clinician and we had only chemotherapy to attack the cancer, it was sort of like saying to a fireman, here's a forest fire, put that fire out with a shovel. And okay, he can sort of hold it back for a second, but eventually it would just race over. And I think in this new world we're talking about now, we now say that we have biotherapies, immunotherapies. We're saying we're going to really attack the cancer in multiple ways. We may use a virus to infect and destroy it. We'll call on the immune system, immune cells. We'll bring in antibodies. There's a great lot of exciting stuff about antibodies that can activate, which is the treatment that Ramona got, and put these things together to really try to make therapies that have a better chance of being successful in patients. And that's really what we're all about. So thank you very much for your attention.
Thank you, John. And I know that many of you probably have questions, but we will hear from both of our other guests before we break out into a group conversation. So jot them down or otherwise try to remember them. And we'll, after hearing from our next two guests, we'll get to those questions. So it's my great pleasure now to introduce, and to meet actually, Dr. Marcus Butler. He's the clinical head of the immune monitoring team at the Princess Margaret Cancer Centre, which is part of the University Health Network in Toronto. He's an assistant professor at the University of Toronto. And before joining the Princess Margaret Hospital, Dr. Butler was an instructor in medicine at the Harvard Medical School and a clinical fellow in medicine at the Dana-Farber Cancer Institute. Dr. Butler's expertise includes clinical trials in a variety of immune therapies, including adoptive T-cell therapy and checkpoint blockade. I actually have a sense of what that is now after the last little bit, and you will too after his presentation. You'll be impressed with yourself how you can catch on. In his lab, Dr. Butler and his team work to engineer an immune response by taking cells from a patient's own immune system and modifying them to fight cancer more effectively. Essentially, they supercharge the immune system. Dr. Butler, please.
Okay, so my task is to sort of give a little bit of an introduction to some of the immune therapies that are being currently used in the clinic. So the first thing I thought would be helpful to review is, what is going on with patients' immune systems at baseline without doing any engineering of the immune system to try to induce immune responses. We actually, many patients with cancer already have a low-grade immune response against their cancer, even in patients who have progressive disease. And what's going on here is that the immune system has these little aspects, there's not the immune system, the cancers have these little aspects called antigens that are different than normal cells, or at least expressed in a way that's different than the normal cells. And the immune system is able to recognize those antigens. They present the antigens to the immune system, typically in a lymph node or sometimes in lymph node-like structures that are elsewhere, maybe in the tumor. And then these immune cells are able to traffic back to the tumor and hopefully target and kill the tumor cell. The problem is that the immune system has a lot of balance and checkpoints that prevent an overactive immune response against these antigens. And cancers, being sneaky and smart, figure out ways to subvert that normal response of the immune system and are able to either hide from the immune system or downregulate the immune system so that the cancer is successful, grows, and becomes a problem. So recently there have been several new drugs that have become part of medical oncology. Both of those types of drugs were mentioned by Ramona when she described the treatment that she received. One of them is Yervoy, which is used really only in melanoma. It's also called ipilimumab. Some people call it IPI. And it's a very important drug in that it was the first immune checkpoint inhibitor that has shown really significant survival in a minority of patients with melanoma in a way that's quite meaningful, and we have a lot of long-term data from patients that receive that drug. And then there's a whole slew of other drugs that have gained approval or are about to gain approval that target the PD-1 molecule that's on T cells or PD-L1 that's often on tumor cells. And what this molecule is partly involved in is downregulating the immune response by allowing tumors to have expression of a way to interact with PD-1 and then downregulate the immune response. So what's really kind of remarkable about these immune checkpoint inhibitors is that there's been quite a lot of responses in patients, many different types of cancers. CTLA-4, as I mentioned, or ipilimumab, that targets CTLA-4, has been approved for the treatment of patients with melanoma, and the response rate, unfortunately, is low. It's only about 10% as a monotherapy, but for those 10%, it's quite meaningful. Then the anti-PD-1, anti-PD-L1 drugs have shown responses in diseases like lung cancer, triple-negative breast cancer, kidney cancer, oral cancers as well. And then the anti-PD-1 drugs have higher responses seen in melanoma, bladder cancer, stomach cancer. And then what's remarkable also is that combination therapy is showing even better responses in patients. Now, what's very exciting is that these types of drugs that are targeting immune checkpoint inhibitors or other molecules that are on the cancer-fighting T cells, is that science has identified many different types of molecules that we can target, and we've only really hit the very top of the heap in terms of things to study in people. CTLA-4 and PD-1 have been targeted, and they're now drugs that are approved and are being used in the clinic. But there are several other similar types of immune suppressive molecules that are found on T cells, as well as molecules that activate the immune system. So there's quite a lot of excitement in terms of revving up the already basic ongoing immune response. And the reason why we are excited about this and why it really is a game changer is because even though the percentage of patients might be low in some of the older studies, the patients who do achieve a response can often have very long-lasting responses. This is the first study that was done in melanoma where patients, if you're on this curve, survival curve, this is 100% of people are alive, and then as time goes on, patients die and the curve goes down. For patients who received a vaccine, they did worse than patients who got Yervoy. And then out here at 3 years or so, patients who are remaining alive are not passing away from relapses after that time point. The immune system is able to induce a response that is long-lasting. So now we're hoping that with these newer drugs, like anti-PD-1 drugs, pembrolizumab or nivolumab, that these drugs will also induce not only high responses, but also responses that can be very long-lasting and can last for many years. This is data from the Yervoy Yervoy studies where patients have been followed for 10 years. And if you made it out to 3 years, then patients continue to do well without relapses. So that is, we often try, and as cancer doctors, not to talk about cures because we're afraid of disappointing people. But if you're able to live 10 years without a relapse, then that's very suggestive of something very exciting and different than what we've ever seen before with chemotherapy in patients who have disease that's already spread. Now, the problem that we have is that patients who are able to have these immune responses to the treatments where we're just manipulating the immune system, it really requires that the immune system has already got the ball rolling and that there is a baseline immune response started. So this is where we start talking about hot tumors versus cold tumors. Hot tumors where there's a smoldering immune response that just needs to be tipped over the edge with a few drugs to try to enhance the response. But for patients who have cold tumors, unfortunately, the responses that we're seeing are not as high in terms of percentages, and there are a lot of people that just don't benefit from the treatments. Now, some of the strategies that have been used are to do combination therapy, such as adding more of these immune checkpoint inhibitors together, like anti-CTLA-4 with the anti-PD-1 drugs. And it turns out for melanoma that we're adding about 15% more people are having responses, but survival may not be significantly different from patients who get one drug and then get the other drug if they have disease that progresses. But in any case, we do see a higher response rate. But also there are strategies to combine treatments with other immune checkpoint inhibitors or other types of ways to rev up the immune response. And then you're going to hear in a bit about taking T cells and engineering those T cells to recognize the tumor so that you can take a T cell that recognizes the flu or some other antigen or other virus and then direct it to hit the tumor. And in the interest of time, I'll stop here and we'll be able to talk more in a few minutes.
Thank you very much, Dr. Butler. Our next presenter is Dr. Harry Atkins. He's a physician at the Ottawa Hospital Blood Marrow Transplant Program, an associate professor of medicine at the University of Ottawa, a scientist in the Centre for Innovative Cancer Research, and the medical director of the Regenerative Medicine Program at the Ottawa Hospital Research Institute. He specializes in the management of patients requiring stem cell transplantation, and he has spearheaded the use of stem cell transplantation for immune repair to treat patients with severe autoimmune diseases, in particular multiple sclerosis. He has also developed clinical trials exploring the role of dose-escalated radiation therapy to treat refractory blood cancers. You're going to have to explain that one. His laboratory research includes a long-standing and fruitful collaboration with Dr. John Bell, developing oncolytic viruses, particularly for the treatment of hematological cancers as personalized cancer cell vaccines. Please help me welcome Dr. Atkins.
Thank you, Linda. So I want to talk a little bit about these new treatments that are just starting to enter clinical practice called chimeric antigen receptor T cells, or CAR cells. And this is really a new form of cellular immunotherapy for cancer. And it builds upon some of the expertise that we've known about for many years, but maybe I want to start the story here. So we do donor stem cell transplants, and despite what John thinks about, new ideas in immunotherapy, we've been doing immunotherapy in the form of bone marrow transplants for about 60 years now. Not me personally, but the field. And so in this field, what we do is we have a healthy donor, Kevin on the left, your left here, and he gives bone marrow or peripheral blood stem cells. This is a product that's got stem cells in it, but it also has a lot of immune cells in it. And we take that and we may process it. But eventually they will come out and we will treat Stuart with chemotherapy to wipe out his leukemia or his cancer and his immune system. And then we'll stick in Kevin's stem cell product. And that will grow into a new immune system. And because that immune system started in Kevin, it recognizes Kevin and it's quite happy with Kevin's body, but it's not so happy with Stuart's body or Stuart's leukemia. And so it will attack that. And that's called a graft versus leukemia. That's the positive aspect of immunotherapy as we've been practicing it for the last 60 years. Unfortunately, there's a kind of Dr. Jekyll, Mr. Hyde kind of thing, and we have this other problem called graft versus host disease, where Kevin's immune system recognizes Stuart's body and starts attacking that, and it can make Stuart quite sick. And so the problem with this practice of immunotherapy, we know it works, we know that it accounts for about half the cures that we see after bone marrow transplant, but it also accounts for about 15 or 20% of the deaths that we see from bone marrow transplants as well. So it tells us bone marrow immune therapy, very powerful. Also tells us that it's almost like a nuclear reaction, right? So when we do it right, and it's like a nuclear power plant, everything's controlled. When we do it wrong, it's like an atomic bomb, and results aren't so good. And so we've been looking for new ways to figure out how to control the immune system. And that's where this interesting CAR cells has come about. And so I'm going to give you the 101 of what I understand about immunology, which is not so much. But it starts with a target, a cell. So that could be a cancer cell. And it has something on it that is recognized by the immune system. We call that thing an antigen. And it's presented in the context of special molecules on the surface of the target cell called HLA molecules. The T cells, or a certain kind of immune cells in our body, recognize that each one has a different recognition domain on it. So it's like having a bunch of different books in a library. All these T cells are different. And there are certain ones that recognize the antigen on the target cell. And when that happens, we get a first signal that tells the T cell, oh good, we found the right thing, let's start doing what we're supposed to do. And that's followed by a second signal that tells us, let's blast this thing away. And we get an immune response that kills the target. And so in the immune response, for a T cell to work, you need these three things. You need antigen recognition, you need signal 1, you need signal 2. And so some brilliant people decided to make a special gene that has a target recognition site, signal 1 and signal 2 built into it. And they've managed to, through the power of genetic engineering, to package all this into a virus. And we call this virus a Lenti virus. It's a unique package that has ways of getting into cells. And like John had said, it's able to take over and reprogram the cell that it infects. And so we use this lentivirus to infect T cells, and the lentivirus directs the T cells to produce this molecule, this CAR molecule that has a target and signal 1 and signal 2 domains. And so what happens now is when we have a leukemia cell that expresses this special antigen, and in leukemia that we're working with, it's called CD19. And that's because it was the 19th one. Yeah. And so the T cell will recognize it through the CAR, not through its T cell receptor. And when that binding occurs, then we get signal 1 and signal 2, and we get destruction of the leukemia cells. And this has turned out to be a very powerful technique. And now, instead of having to go find a donor like Kevin, who might or might not like to be a donor, we can take Stewart's T cells and we can harvest them and engineer them with this lentivirus in the lab, and then go back and transfuse them into Stewart after we give them a little bit of chemotherapy, and we can wait for these T cells to recognize the leukemia cells and start killing them. And this has been very powerful, and perhaps the best story is one of the first ones done. So this is a story that's well known, and a result of the first clinical trial of this technology by its inventors in Philadelphia. And so they had a young girl with acute leukemia. She had developed it in 2010, and she got chemotherapy. It went away, came back, went away, came back. That's a bad situation when leukemia comes back. It's not it's very, very rare for that to be cured. And poor young Emily was in dire straits and was felt to have just a short while to live. And so she was approached to go on this experimental therapy, and her parents agreed. And then I think a picture's worth 1,000 words. And so here's year 1, year 2, year 3, year 4. And so these cells have been very powerful, and again, I want to put in the caveats that all my other colleagues have put in. So when these work, they work very well. They're not without side effects, and so this is not like, this is an interferon-like treatment. It has lots of side effects, but when they work wonderfully well. But they don't work all the time. But the beauty of this system is that we can genetically engineer the viruses so that they look at different targets. And there's a huge research effort, ideas that we've heard about here at the meeting, ideas that are done by other scientists around the world with ideas of how to make these CAR cells better, how to make the genetic engineering better so they're more powerful, they recognize the targets better, the targets are more selective. And so this is a field where we're starting and we see some successes, but as we move ahead in 2 years from now, 3 years from now, 5 years from now, I think we have the option or the possibility of better and better treatments using this technology. I think I'm going to stop there, and thank you.
Thank you very much, Harry. That was wonderful. All three of you. So just recently I came across the origin of the word cancer. And I learned that it was actually named by Hippocrates some couple hundred years BC. And cancer comes from the word carcinoma. Carcinoma being the Greek word for crab. And because back then when you identified cancer, when you identified the disease in one of your patients, it was a hard mass, like the shell of a crab, because you got it late. It was too late to certainly do anything about it. And he described the pain that his patients experienced as a crab's claw, just torturing the person. And, for a long time, that was a long time ago, but for a very long time, we thought of cancer as that mass that killed, that death sentence. And in the last couple of days, and I hope in the last couple of moments, you have realized that there's so much more at play. And it's I used the word dizzying earlier, but I can't think of another one. Every hour somewhere in the world, someone discovers something new about cancer, whether it's about the treatment or about the disease itself. And so certainly very exciting times. And I can just feel the excitement in the room. Come on, let it know. You have the next half an hour to ask questions that you have been wanting to ask for a long time, and to have a conversation about where we're at now, maybe where we're going. There are no rules, guys, right? You ready to take any questions? You game? They're game, believe me. They'll get into it. So the way it works is you need to step up to one of the mics and ask a question. This will be recorded, so if you're coming up to a mic, you're likely to be caught by the camera. And it will be available for you to view on BioCan's website. So great, opportunity to hear again this wonderful learning that we've taken part of tonight. So who might want to be the there we go. Congratulations, you're the first one.
Thank you. BCG for bladder treatment. How effective is it? What's the long-term prospect? Is there anything better than BCG, which I have read? And I'd like to know more about it.
Well, I'm not a bladder cancer doctor, but so that's for superficial bladder cancer that's been removed to try to prevent it from any spare few cells left behind, to make sure that you get rid of them. And what BCG does is it induces an inflammatory response in the bladder, and then hopefully gets rid of any of those spare cells that are left behind by the surgeon. The BCG does not work in patients who have disease that's spread. Chemotherapy can be helpful, and also the new immune therapy drugs, the anti-PD-1 and anti-PD-L1 drugs have gotten approved for patients with distant bladder cancer. The studies to look at whether immune therapies should be used in high-risk patients early on to prevent cancer from coming back are probably in the process of being done. But like I said, I'm not a bladder cancer doctor, so I can only speak from what I've heard. Any thoughts?
Not very many, because that's even further removed from what I do. But again, this meeting, we had a presentation by a young student and a lab where they're looking at some of these viruses. So rather than stimulate inflammation in the bladder to induce or to start an immune response against the cancer using BCG, which is the vaccine for tuberculosis, they're using the vaccine, a virus that's the vaccine for smallpox called vaccinia. And so people are trying new things. That's a very new trial, so it's just at the beginning. And so it's hard to know if that'll work at all or whether it'll work better or worse than BCG. But again, there are lots of people trying to find better ways to improve on what we can do already.
I have a question. It refers to one of your last points up there, Harry, but it's for all three participants. You mentioned when the treatment works, it works really well, often with these immunotherapies, but in a lot of circumstances, there's no response. I happen to know Ramona, and she shared the story previously of someone who had the marker as she did, who was on treatment, but unfortunately, it didn't work for them and they passed away. What are your approaches to increase that response rate, and what are some of the triggers so that it moves up from 30% to 50 to 75% if people have the marker? Why is it working for some people and for others there's no response, and what can you do about it?
So I'm going to start rightly or wrongly. So we've talked about different parts of the immune system almost in isolation, and yet the immune system is a very complex part of our bodies that have lots of different components, much more complicated than a car engine, for instance, or a rocket. And so everything has to work in the proper order at the proper time to get a good response. And I don't think that, well, we're much better than we were 10 years ago or 20 years ago, but there's still a lot for us to learn and a lot of tools to create to be able to refine how we can control the immune system. And so people are working on that, and we try to get them into our clinical practice as quickly as possible. But until we have that better handle on how to adjust the knobs and put all the pieces into place so the machine works the way we want it to, we're going to have this problem where we sometimes have overactive immune systems that react against things we don't want, and we're going to have other situations where it just won't turn on because we don't know the right trigger, and then we'll have the happy media in the middle part where we just got things right. And the more patients that get treated and the more experience there is using all these different agents, the better our understanding of the immune system, and that'll improve our response rates and our treatment outcomes.
We're just now beginning to understand some of the mechanisms of resistance for the new drugs that have recently been approved. And there's a concerted effort to try to get samples from patients to do a deep dive and to understand what's going on in those patients. That requires a kind of shift from the old days where you give a treatment, it doesn't work, then move on to the next treatment, but not really put patients through extra biopsies or extra tests. But rather, what we need to do is to try to build on successes that we've had, and when we don't have success, build in a way to analyze what went wrong, and maybe that'll help guide us to give the next therapy that will be more effective. And the sort of mechanisms that we're finding are that it might be that the immune system or the tumor has put up additional defenses against very effective army of killers that want to kill the cancer but just can't. Or it could be that there hasn't been a successful recruitment of army to go after the cancer. So the idea that we all have is to try to combine different therapies and then apply those combinations strategically to patients who have certain defects in the way that their treatment is helping to treat their cancer.
Thank you. Your question?
This is a little too tall for me. I'm short. So I have several questions and several thoughts, and one of them is the whole aspect of autoimmune disease and how it seems to people who do have autoimmune, such as myself, have multiple autoimmune diseases, and wonder whether there is a correlation, or if you have looked into the aspect of why the body creates these autoimmune diseases, or resistance to being healthy, and creates these disparities within the body, such as arthritis, multiple sclerosis, all these things that attack the body. Could this kind of therapy go beyond cancer and treat the autoimmune diseases of other kinds of autoimmune disease? Have you looked that far, I guess, is the question.
Well, one of the problems with a lot of because we're activating the immune system in patients with cancer, we often will induce autoimmune type diseases in patients. The difference is that often it's self-limited. We can give treatment, and then that side effect eventually disappears. Most patients with autoimmune diseases have been excluded from these clinical trials, but now because they're approved and we're treating patients, we're finding that you can actually treat patients without making their autoimmune disease worse. That's for these non-specific type of drugs where we're just infusing treatments.
Right. But if you give back the T cell, their own
well,
T cell?
it's kind of, there are some of the suppressive cells that help to prevent an immune response against the tumor can also be used to try to downregulate an immune response. So some people are manufacturing adoptive cell therapy where the cells you're trying to get rid of in cancer patients are actually being put back in patients with autoimmunity. And there are also other strategies that I think John wants to speak to.
No, I was actually to your last point. BioCanRx is actually funding a group in Edmonton to do exactly this. It's a great question, and I think what we're learning from the immune system is, as Marcus said, is how to activate it. But, and Harry said, we have to understand the whole system so we can control it. And so we're now trying to get cell products that could actually dampen autoimmunity. But my colleague, Dr. Atkins, is a world expert on autoimmune disease. Yes, he's well known. So he's done a lot of work over the years with patients with autoimmunity. So Harry, maybe you speak to how you've rebooted the immune system.
That's a good one. I'd like to know how to do that.
Yeah. So again, so the question is a little bit, or the issue is
the premise, I guess,
is opposite to what we're trying to do in cancer. So in cancer, we're trying to take a lazy immune system and get it to fight or attack a cancer.
Right.
In autoimmune diseases, we're trying to take an immune system that's active and suppress it. And again, we don't have very good tools. We have sledgehammers, not scalpels. And so the sledgehammer that I've been involved with developing is really using chemotherapy, very strong doses of chemotherapy and antibodies to wipe out the whole immune system, and then to put back hematopoietic or blood stem cells, which are the seeds of the immune system. And when that immune system grows back, it seems to grow back with better behavior like a baby's immune system. And so it recognizes properly that what's part of the body and not to attack it anymore, and what's a germ and should attack it. And so we've been quite successful with this technology to treat multiple sclerosis, arthritis, a bunch of other neurologic diseases. but it's a stem cell transplant. It's no less risky or eventful than a transplant to treat leukemia, for instance. And so we need to work on ways of making that a easier therapy or a more appropriate therapy. So right now this works for people who are
there similarities in the type of reaction from autoimmune to cancer immunology?
So I think a lot of the ways that the cancer cell, like these new cancer treatments will work, will be very similar to how the cells work in autoimmune diseases.
Interesting.
Yeah, and in some ways, some of the side effects, as Dr. Butler said, some of the side effects of these new drugs are autoimmune-like diseases. Yeah.
That's great progress, guys. I can't.
Thank you for your question.
Hi, my question is about interferno. We heard from Ramona that it was a bad experience, I think, that she had. I want to ask what makes it bad, and if it's really bad, is it dependent on what kind of cancer it's been used to treat, or a combination of drugs with interferon? What makes it bad if it's bad? I have been receiving BCG plus interferon, and so far it's working. So I just want to know what makes it, some people have good experience and others don't.
Well, Dr. Butler actually administers it, so he's
Not very much. Most of my patients don't take it. Well, it makes, this is interferon for melanoma that Ramona described, and it is a non-specific, it's another kind of activator of the innate immune system, but it makes people feel like they're infected with the flu virus. And so if you remember how you feel when you have the flu, it's a flu experience that goes on for about a year. And the other problem with interferon is that it has some benefit, but it's not a particularly high amount of benefit for patients, and so we clearly need to get better than what we have with interferon, and hopefully we will with some of the new treatments that are coming along that are being applied to patients in the early stage where we're trying to prevent cancer from recurring.
Okay. You're next, Louise. No, sorry, Erin, and then you. Sorry.
Okay.
Go ahead.
Thank you. So I actually have two questions. First is around the role of the patient in their treatment. So Linda referred to it early on in the presentation, and I just wonder, apart from forums like this where people can come and find out more information, how can patients find out about different types of treatments? What kinds of questions should they be asking their oncologist? And then my second part of that question is, what sort of results do you need for your trials to become part of the standard of care?
Those are important questions. So I think that patient advocacy groups are crucial for patients to have a community of similar people going through very difficult times, and so and then also the advocates really understand the landscape in terms of where there are experts, and also some of the challenges with getting drugs approved or getting access to drugs depending on the patient's particular situation. Also dealing with insurance companies and other things that come up when a drug isn't fully funded by the public healthcare system. And the way we, in general, clinical trials are used as a mechanism for getting a drug approved. The thing that's important to understand, I don't know, in like 30 seconds, the way things happen in Canada. There are many types of clinical trials, early phase trials and late phase trials, and They're really looking at safety and how well drugs work, and then comparing drugs to standard of care. One mechanism for getting a drug approved is that there really isn't any effective therapy, and then you find a drug that works. And that is the way some of these drugs get approved in rare cancers, where you can't do a big randomized study. Which sometimes happens. It turns out that a new treatment might look good, but it's not any better than the standard. And then after you get Health Canada approval, there is an additional step where the drug is analyzed by a group that looks at how well it works in the current scheme, the way we treat a patient's disease, and then also the economics on whether or not the drug is affordable. And then after that process finishes, then the provinces will go into negotiation with the maker of the drug to see whether they will fund it. And for instance, Ramona's treatment that she's on is a Health Canada approved treatment, but it is not covered by any of the provinces, I believe. It is covered by some insurances, but not by provinces, and that's currently in negotiation with the maker of the drug.
It's quite the process. Anybody else want to add to those questions? Means you did a great job. Louise.
Thank you very much. My name is Louise Binder. I'm with the Save Your Skin Foundation. We're a national organization that deals with skin cancers and particularly melanoma. Before I got involved with cancer, those of you who know me will know that I spent about 18 years working for patient advocates in the HIV community. So I've had a fairly long history with this. My first comment is I'd like to thank you very much for the presentations. They were really wonderful, and I particularly would like to thank you for all the hard work that you're doing for patients, because I know that it's a tough slog, and I know that people in this room really appreciate that tough slog. So thank you for that. Just a few comments and questions. I didn't mean to make this comment, but the person before asked about what questions to ask their doctor. So about 8 years ago, I was involved in helping to create a patient treatment decision guide with a woman who works for rheumatoid arthritis and also someone from Health Canada. So if anybody is interested in getting a copy of that, I'm happy to share it. That wasn't really what I got up to say, but since the question came up, I'm delighted to share that. I think I want to take us in the direction that Marcus was just starting in, which is the issue of how drugs get reviewed, approved for sale, and then approved for reimbursement in Canada. And I know that isn't what you folks are here to talk about, except to the extent that you can create the most wonderful drugs in the world, and they can be as effective as, they can be miracles, even cures, but if we don't have a system that will reimburse them, we're in big trouble. And so I'm not going to get into the details of how crummy our system is on that front, but I think I just want to kind of raise the red flag to everybody that you folks will do all the work that you can do, and then we still may never see them available to people. So I want to really just say to the public, please join all of us in working towards a system that understands the value of paying for these drugs. And those of us who are patient advocates and activists, and I'm not embarrassed to call myself either of those, please join us and help us to make sure that the wonderful work that you're doing actually gets to people in this country, because there's some big questions about whether they ever will. And we want them to.
Thank you, Louise. And thank you, everybody. We're just about on cue. I'd like to take a few minutes to express some appreciation and gratitude to people who made this come together. But I reserve the right to have the last question. Is that okay? BioCanRx. We're, first of all, for those of you who aren't in Ottawa or from Ottawa, go like this right now. But we're so delighted that this is in Ottawa. It's very exciting for us. It means good research, good care in our community, but it has such a broad reach, and it just feels like it's going to really be the disruptor of this century for cancer treatment. So really, thank you for your leadership, Stephanie, your team, John, your team. It's just an honor to watch what you're doing. Very proud. To our other panelists, Harry, of course, it's always a joy. I'd rather hear your sailing stories sometimes, though. But you do great work, and you're such an amazing, kind soul. I know that everybody that you work with as a physician has a changed life. And Marcus, I hope that we meet several times again, because we could learn lots from you, and you're doing great stuff. So it's amazing to be on this stage. I feel so privileged. So thank you for taking the time. I know you're doing great things, and you're very busy. This team, you appreciated what they taught us. Okay, so here's the thing. When you learn something new and you want to get deeper into it and you want to see if you can't wrap your head around it and do something, you go to Google University, or I do, right? So tonight, my normal trajectory would be to go home and turn on the computer and Google, how do I take care of my immune system? And I know some things fundamentally. I have to eat right, and I have to exercise, and every now and then I have to get some sleep. But are there things that you do because of what you know and your understanding of the immune system? Are there things that, is there a little bit of a secret sauce that you have going there? Is there something, vitamin B, vitamin C? What, can you leave us with your thoughts on that?
Red wine's great. Prescribe that ain't. I think, taking care of yourself as you do is I think that's the best thing that we know at this point, because we don't know enough about the immune system to say how to say, eat your broccoli or whatever. But since we don't know, that's why I say red wine's good.
Take care of yourself?
Yeah, take care of yourself.
Don't smoke.
Don't smoke?
Yeah, absolutely.
Yeah, I think
Stay out of the sun.
don't smoke. See your doctor for a regular checkup once in a while. I think that's the best thing.
I'm so sorry. Yes?
It's a good idea, if you can, to exercise, because exercise is good for the immune system, and there have been some really big meta-analyses. Those are like studies done on lots of other studies that show that patients who are fairly fit when they come down with cancer and they keep exercising as much as they can through their treatment, that they tend to have better outcomes. So just...
Thank you. That's all great advice. We are going to want your opinion, and that means it's over there. Is that what that means? Oh, you have the feedback forms. Okay, please. Do take the time to let us know what you thought of tonight, what you'd like to see next time, and we do hope to see you next time. Merci beaucoup tout le monde. Bonne soirée. Jog home.
Congratulate the work of the cancer working people. 20 years ago, I had a bone marrow transplant for non-Hodgkin lymphoma. One of the doctors was Dr. Atkins. I was 62 years of age. And this lady just talked about being physically fit, exercising and everything. It is true. I am now 82. And I hope to live to 102. Thank you.